search for higher quality ride and handling is of paramount importance to motor manufacturers. Suspension parameter measurements that are both accurate and cost-effective are vital to design and development engineers. Anthony Best Dynamics personnel have been providing this service for some 25 years. The company also offers an unparalleled service in consultancy, design and development, with particular expertise in vehicle suspension, noise and vibration. The experience gained and the relationships developed with the world's leading automotive manufacturers has led to the design and development of the Suspension Parameter Measurement Machine, or SPMM. The basic philosophy behind the SPMM has been to design and develop an easy-to-use, rigid and reliable machine using software that is flexible enough to allow a wide range of tests and a mechanical design that, using modern computing power, maximizes the capability of the whole rig. The machine measures the quasi-static vehicle suspension characteristics that have a significant effect on ride and handling. These measurements are essential to the thorough understanding of the vehicle's performance in terms of ride, steering and handling. They can provide input data for computer modeling of vehicle handling or to compare vehicles and assess them against stability criteria. To keep testing time to a minimum, the standard machine tests all four wheels simultaneously, allowing the most commonly required tests to be completed in less than a day. A two-wheel station version of the machine can also be supplied at a lower price. A full set of tests can be carried out by installing the vehicle forwards and then backwards. The two-wheel station SPMM is designed to enable it to be upgraded to a full machine at a later date. The standard machine comprises four main areas: the central roll pitch bounce table, the four-wheel stations, the measurement system, and control and data collection software. The machine subjects the vehicle's suspension and steering system to a variety of forces and displacements relative to the vehicle body. It measures the kinematic characteristics due to the suspension and steering geometry, and the compliances due to springs, anti-roll bars, elastomeric bushes, and component deformations. Driven entirely by DC servo motors, there is no requirement for hydraulics, which are noisy and prone to leak fluid. A wide variety of measurements can be recorded by the SPMM. For instance, in a bounce or heave test, the loads on the tyre pad are measured and the deflections of the wheels relative to the ground are measured. Similar measurements can be recorded when the vehicle is rolled or pitched. To establish the horizontal plane compliances, each wheel pad can be driven laterally or fore and aft, loading the suspension as in cornering or braking. The steering system compliances can be measured by applying a torque at each wheel pad. Alternatively, the steering system can be driven using a specially designed motor drive to simulate driver input. The body of the vehicle is clamped to the central table, which can move in roll, pitch or bounce to enable kinematic measurements to be made. As an option, the capability of the SPMM can be increased to provide moment of inertia measurements. In this case, the central table is also driven in yaw. The central table is designed to be very stiff, avoiding any erroneous deformations. It can also hold the body stationary. The motion of the central table is controlled by 6 electrically driven roller screw actuators, 2 fore and aft, 3 vertical, and 1 lateral, all computer coordinated to ensure the motion is true. Considerable care has also been taken to achieve the minimum backlash. To achieve this high degree of fidelity, we have designed and built special universal joints, incorporating pre-loaded taper bearings at one end of the actuators, while the other end uses high-quality spherical joints. The resolution of the actuator is much finer than the backlash of the joints, and the positioning accuracy of the table is extremely high, typically 0.1 millimeter. The wheel stations use linear roller bearings for both the lateral and the fore and aft motions. Motion is provided by ball screws motor-driven through toothed belts. A further motor below the turntable provides rotation about the vertical axis. At the heart of the load measuring system is a multi-axis load cell, which can measure the 3 orthogonal forces and 3 moments applied to it by the tyre. A choice of piezoelectric or strain gauge load cells can be fitted, but we recommend using the piezoelectric device made by Kistler, which is sensitive to very small force changes even in the presence of high static loads from the suspension. The deflections of the road wheels due to the tyre forces applied to them are measured using digital string encoders mounted on stands beside each wheel station. The encoders incorporate a precision spring-loaded spool with stainless steel wire wrapped around. As the end of the wire is moved, the spool rotates, taking with it an optical encoder. The output from a series of encoders is used to compute the lateral, longitudinal and vertical movements of the wheels, as well as changes in camber and steer angle. These encoders have proved to be versatile and reliable, a typical resolution of 0.025 millimeters. Caster change can be measured by means of a servo inclinometer attached to the hub carrier. The servo motors driving the rig are controlled by a highly reliable multi-axis programmable controller, which receives instructions from the supervisory user interface program. Designed to run under Windows NT, this program provides a modern, easy-to-use control environment. A database is used to store vehicle and test data. A new record is created for every vehicle tested. It stores basic information such as vehicle type, manufacturer, dimensions, and suspension details, as well as important project-related data. The test specification contains all the information needed to run a test. Cycle time, number of cycles, force or displacement limits, type of control on each axis, and range selection data for the Kistler load cells. A typical test takes 2 minutes, from which all results are stored in a separate binary file, which is accessible for post-processing. During a test, results can be plotted real-time to give instant information on the progress of the test. The plotting program can automatically select the correct graphical display for each type of test from a set of stored plotting templates. Post-processing is carried out using a commercially available plotting and mathematics package, which allows automatic processing and plotting of results upon test completion. The graphical output and post-processing calculations can be customized to the requirements of every user. A large number of parameters are derived from the measurements, such as roll centers, anti-lift and anti-dive tangents, and steering system parameters. The control and management of the rig is flexible enough to allow your experienced operators to not only carry out existing tests, but also to devise new ones that suit your vehicles and your practices. The suspension parameter measurement machine provides an enormous step forward in measuring suspensions, an essential tool for the motor industry worldwide.